Hello, welcome to the Day 7 notes on analyzing graphs of polynomial functions, section 6.4. So what we're going to be doing today is we're going to be graphing polynomial functions on our calculators, and we're going to locate their zeros and relative maxima minima also using our calculators. So let's go ahead and define some key words here. Zeros shouldn't be a new word for you. Those we've done before, and these are the x-intercepts of a graph. So they're basically the points where the graph will cross the x-axis, where they're zeros. Relative minima and maxima. Now this is a bit new. A relative maximum is the highest point in a certain area. So when we're going to be looking at these graphs, it's basically going to be like the hilltops. It's the biggest y coordinate in a certain area. The relative minimum is the lowest point in an area. So if you're looking, these are going to be the valleys. Turning points occur at the maximum or minimum. And basically, the number of turning points is going to be at most one less than the degree of the function. So when you're graphing a second degree function, the most turning points it will have, the most maximins, is 1. If you're graphing a third degree function, the most it will have is 2. Now that means it could have less, but at most it will have 1 less than the degree. So let's say it was a 98th degree function. The most amount of max mins, so aka turning points that it would have, would be 97 because it's 1 less than the degree of the entire polynomial. Again, it could have less than that. It could have only 3 or whatever, but the most that it would have is 97. Let's take a look at a type of polynomial function that we're going to be graphing today, and let's define some of these points. Notice here the graph is crossing the x-axis. This is called a 0. And then the maxes are going to be the hilltops. So right here, there's a relative max. And then I see another one over here. It's a relative max. Now what I want you to notice about the second relative max is it is also a 0. So when you're going to be labeling these, you do have to realize when a max or min happens to also be a 0. And in this case, it is. The maximum, the hilltop there, is a 0. And then we have a minimum here. It's the valley. So this would be the relative minimum. We also have here a 0 that I almost missed, but it's right there. It's crossing the x-axis, so that's a 0. Alright, so how are we going to find all these points once you have an equation and your calculator in front of you? What you're going to do is plug the equation into y equals. Zoom 6 to make sure you're in the standard window from -10 to 10 in the x direction, -10 to 10 in the y direction, and you're going to look at the graph and determine which of these points it has. To find them, you are always going to be on your calculator. What you're always going to do is press second calc, and underneath that calc menu you will find all the things you need to find: maximum, minimums, and zeros. What you're going to do then is exactly what we did in Chapter 5 with parabolas. It's going to ask you, so when we found zeros before, it would ask you for a left bound point, a right bound point, and a guess. For max mins, same thing, except now we just have more of them. In a parabola, we had at most 2 zeros and only 1 max or min. Here we're going to have multiple ones. One last thing that I'm going to mention about this graph above is turning points. Remember, turning points occur at the max and mins, and so if you notice, our graph, if you're looking left to right, our graph here is going up. It's increasing in value, increasing at the max. It turns. It's a turning point, so it literally changes direction. Instead of going up, it's now going down. We get to the minimum, changes direction. Instead of going down, it's now increasing, and at that last max, it again turns and switches directions. Right, so our first example here, notice that I pre-graphed it for us, but we're going to put it on a grid anyway, so we're just going to pretend, but I'm just going to talk you through it. We're going to graph f of x equals x to the third plus 2x squared plus 1 by making a table of values. Your table needs to have all maximum or minimum points and zeros rounded to the nearest hundredth. Then we're going to graph it. So the way I like to set up my table is before I even start calculating anything, from left to right, so I'm looking at the graph this way, I label all those important points that I've defined. So the first important thing I see is a 0. So in the table, I'm going to write 0. So I know that's the first thing I find. Moving along left to right, I see this point, and that's a max, because it's like a hilltop. Left to right, here I see a min, because it's a valley. Alright, so you're going to take your calculator, press second calc. So right here, you're at second calc. I would go left to right. So these directions, even though it says find max or min first and then 0, I just do left to right. So the first thing I'm going to do is second calc, and I'm going to press 0. Remember, to calculate the 0, what you want to do is put your cursor, because your cursor is going to show up, put your cursor on that 0. At this point, it is asking you for a left bound. Arrow over to the left once, press enter. Go back to the 0, because now it's asking you for a right bound. Arrow over to the right, press enter, and now it's asking you to guess. You're going to go back to where that cursor was, more or less on that 0, and press enter, and on the bottom of the screen it will give you the x equals and y equals, the values of that 0. For this example, you should get that it's negative 2.20, because we're rounding to the nearest hundredth, and then 0. The fact that the y is 0 shouldn't be a surprise, because at an x-intercept, the y value is always 0. If you get something different than that, that means you made a mistake. Go back and make sure that every time you find a 0, the y value is in fact 0 when you calculate it. Alright, so now we're going to second calc max. We're going to do the same thing. We're going to put our cursor more or less on that max point. It's asking us for a left bound. Scroll to the left once, press enter, then go back to the max. It's asking us for a right bound. Scroll once to the right, press enter. It's asking you for a guess. Go back to where you think that max is, press enter. And on the bottom of the screen, you should get negative 1.33 and then 2.19. So that means the height of that hill right there is 2.19, that max y value. Let's do the same thing for the min. Second calc minimum. Put your cursor on the minimum, scroll to the left, press enter, go to the minimum again, scroll to the right, press enter, go to the min, enter, and on the bottom you will get 0, 1. Some of you may notice that that point right here, that's the y-intercept, because the x value is 0. We're not going to be looking for that specific point. It just so happens that this problem, it's also the minimum. So the point where the graph crosses the y-axis happens to be the minimum of that graph. Alright, so now when you sketch it, because you're going to have to sketch it, this up here I put there, that's not always going to be there. You're going to have a grid, you're going to have to sketch it. So you're going to go to negative 2.2, so comma 0, that's your 0, negative 1.33, 2.19, so more or less there, and 0, 1. And then you're going to look at your calculator and draw that graph. One way that you can make sure, too, that you plugged it in correctly is the end behavior. Originally, this was a degree that was odd, and then the leading coefficient was positive. Odd and positive is like a line with a positive slope. So the end behavior does match because it's up on the right, down on the left. Alright, let's go ahead and do part B. We're going to graph negative x to the fourth plus 3x to the third minus 4x. We're going to make a table of values with all those important points. So left to right, let's highlight what points we're going to be finding. The first one is a 0. Left to right, then we have a max. Then it crosses the x-axis right there, so that's a 0. Then we have a valley, so that's a minimum. And then we come and our max happens to also be a 0. Right, so for all of these, it's second calc, and then you decide which one it is. The first one's a 0. It's going to be at negative 1, comma 0. Then we have a max. It's at negative 0.59, 1.62. At this point, you may want to just pause your video to make sure that you're also getting these values. Okay, so then our 0 is at 0, 0. The next one is 0.84, negative 2.08, and then our max slash 0 is at 2, 0. So notice all my zeros, all of them here, the y value is 0. It should be, because it's the x-intercepts, and the x-intercept, the y value is always 0. All right, let's go ahead and graph this. So negative 1, 0, we'll put a point there. Negative 0.59, 1.62, 0, 0, 0.84, negative 2.08, and then 2, 0 is our max. And we're going to copy that graph, more or less, and we have sketched our graph. And again, notice that the degree of this function was even, so it's going to have the end behavior like a parabola, and now the leading coefficient is negative, so it should be going down on both ends, and it is. What I also want to bring your attention to is the fact that this was a 4th degree polynomial that we were graphing. So the max number of turning points it could have was what? 1 less than that. So 3, and it did have. It had 3 max slash mins. Just remember, it didn't have to have 3. 3 is just the max number that it could have had. This one happened to have 3. So if on your graph you had 5 or 4 even, anything more than 3, you know that you did something incorrectly. Okay, for part C, I would like you to attempt to graph this polynomial on your own. Again, make sure in your table you have all those important points, the zeros, the max, and the mins, and then sketch your graph. So pause it and compare it to mine. Okay, so here's the table of values that you should have gotten and the graph that you should have gotten. Let's make sure that the end behavior is appropriate for this graph. It's an even degree function, so it should be like a parabola, and the leading coefficient is positive, so it should be like a parabola opening up, and it is, so we did it. Okay, here for example 2, we're actually going to not do that. We're not doing that this year, so just cross that out. But really what it was is just finding a max and min, so should have been able to do it anyway. Okay, and then the last example, the last few problems of your homework or classwork are going to ask you to sketch a graph, and then they're going to give you certain criteria for what this graph needs to include. So what I draw could be different than what the next person would draw. And if I draw this now, it could be different than when I draw it again, but at least it's going to have these characteristics that are given. So we want to sketch an odd function whose zeros are at negative 2, 1, and 4, and it has a positive leading coefficient. So you always want to draw in either your zeros or your max mins, whatever they told you to do, you want to put those in, draw them first. So I'm going to draw a dot at a 0 of negative 2, so the x-intercept where it crosses the x-axis is at negative 2, positive 1, and then also positive 4. Now they gave me 2 other important pieces of information. It's odd, and it has a positive leading coefficient. So how would it look? The end behavior has to be like a line with a positive slope, because that's an odd with a positive leading coefficient. So when I draw this in, I'm going to start down here, because that's how my end behavior has to be. I'm going to go through my zeros and end up on top. So now I'm going to show you how I could have drawn this without drawing it like red. I'm going to draw it in green. Let's say I came up, and as long as my criteria is met, it could look something like that, because the end behavior matches, the zeros are where they need to be. And again, so the way I draw it could be different than how you draw it. One last thing I'm going to talk about with this problem is in the homework, it's going to say something like it has a minimum at x equals, let's say, 3. So if this one had a minimum at x equals 3, what that means is I go to x equals 3, and I wouldn't dash it in, but I'm dashing it in so you see what I'm talking about. It would have to have a minimum somewhere along that line. So what I would do is just anywhere draw a point, and then when I would draw that graph, let's say I would draw it like this then. So now there's a minimum value there, somewhere along x equals 3. No one said where it has to be, but it has to be a valley. It could have been a little bit higher, it could have been a little bit lower. That was my decision. I could have put it all the way down here if I wanted, then I'd just have to extend the graph down. I could have put it over here. As long as it's a valley, it's your choice, and that's why each graph could look different. All right, that's all for today. Thanks for watching. Bye.